Hey folks, how's it going? This is Mr. Murray coming to you with a fourth video in the Changing Forms of Quadratics series. This video is meant to be a follow-up to Changing Forms of Quadratics 3. If you haven't seen that video, I'm going to go ahead and link to that video, so see the link that's coming up now. And if you click on that link at the top of the screen, it's going to take you to the beginning piece of this video, right? The one right before it, that I'm going to refer to throughout this video. So it might be confusing if you haven't watched number 3. Okay, this kind of problems is going to cover expand out will not fail. The kind of problems you're going to see there are going to be the medium ones and the spicy ones. So on expand out will not fail, at least as of the date I'm shooting this video, medium problems talk about this stuff, and so do spicy problems, but only the medium and the spicy. So what I'm going to be doing is I'm going to be picking up on how to go from vertex form, which is a times x minus h in parentheses square plus k, into standard form. What we learned in video 3 was that we're just basically building off of what we've already done with intercept, going from intercept form, except now we're doing the box with x minus h and x minus h. Okay, so again, when we went to standard form, we built up this little note, this little notation system for how we do expanding. This we talked about in video number 1. Then in video number 3, what we did is we talked about how do we use this with when we have vertex form. And so what we learned is that we essentially are just taking this thing and squaring it. And we talked about how, well, when you're squaring something, you're multiplying by itself. And so what we did is we used that box method system from video 1 in a situation where we have a square. All right, and we developed this little process where we use the box method to expand out the square, and that's the same box method from video 1 and 2. Distribute the a, assuming it's not 1. If it's 1, then whatever, you just leave it, because 1 times anything is itself. And then if there's a constant outside, like in this case negative 44, you combine that, you add or subtract that at the very end. And this is based on the idea of PEMDAS, right? First doing the exponent, then doing the multiplication, then doing the addition or subtraction. So in this video, what I'm going to do is there's going to be 2 I do problems, 2 we do problems, and 2 you do problems. So this is going to be more opportunity for me to show you different cases of switching from vertex form to standard form. Okay, and let's see what we get. So first, we got g minus 7 squared minus 30. Okay, so remember, the first thing you do is you do the box on the thing that's being squared, because exponents come first in PEMDAS. Well, relative to what we have, right? We're not going to worry about parentheses. So this is g squared. This is negative 7g. This is negative 7g. And negative 7 times negative 7, that would be 49. So we've got g squared minus 14g plus 49. Now a is 1, so we just leave it as is. And then we put on our minus 30. And these are going to combine so that we have g squared minus 14g plus 19. All right. So please make sure you understood what I did here. If not, feel free to rewind, but then in a second I will move on to the next problem. Okay, now here's a little bit more of a challenging one. So remember, the idea behind this is PEMDAS. Now, parentheses, those are taken care of. We don't have anything we really need to worry about there. So the things we really need to worry about are exponents, multiplication, division, and addition and subtraction. So let's not forget our basics here. We have to do it in that order. So the first thing we need to do is we need to do the exponents. And that means we need to first do n minus 36 and n minus 36. So that's n squared minus 36n minus 36n. And then I recommend you turn to a calculator. It can be your phone, it can be Desmos, it can be Google, whatever you want, but you need a calculator. This is 1296. Okay? So here, because a is not 1, I'm going to bring that down. Remember, you never ever distribute into here. Okay? Because then you're essentially saying you're overlooking. To distribute in is essentially overlooking that you have to do the exponent first. So, n squared minus 72n plus 1296 plus 2. Now we distribute the 3, so the next step, right, in PEMDAS would be multiplication, distributing the 3, or in this case the negative 3, so negative 3n squared plus 216n minus 3,888. And then, parentheses gone, plus 2. So the final answer is 3n squared plus 216n minus 3,886. I wouldn't be like, hopefully you're not spooked by like the big numbers, because this is stuff that you always will have a calculator to be able to do. Focus more on the process here. Focus on the idea of first doing the box on the thing that's being squared to expand that out. 2, distribute any a value, assuming it's not 1. If it's 1, then that is basically already done. And then add whatever is on the end to that constant. And if you can just do that process, no matter what the numbers look like, you're going to arrive at the right standard form. So again, please make sure you understood what I did here, or rewind if needed. And then in a moment, I'll go ahead and move on to the next problem. Okay, so here's one for us to do. So in this one, I'm going to seek a little bit more feedback from you, and we'll work through it together. Okay, so here I've got c plus 8 in parentheses squared plus 12. My first step here is going to be to make what? To make a box. What's going to go on the top of the box? C plus 8. What's going to go to the left of the box? C plus 8. So then I fill it in. C squared, 8c, 8c, 64. So I get c squared plus 16c plus 64 plus 12. I'm done here because a is 1. And then what do I do last? I combine. So c squared plus 16c plus 76. Okay, so please make sure you understand what I did there. Rewind if needed. And then in a moment, I will go ahead and move on to the next problem. All right, here's another one for us to do. Notice the pattern here and how they're similar to the previous one. So again, the first thing I'm going to do is I'm going to start by making the box. If you said the box, very good. Or something equivalent, very good. On the top and the sides, y minus 25, y minus 25. Great. So here I'm going to have y squared. Here I'm going to have minus 25y. Here I'm going to have minus 25y. Here I'm going to have 625. Remember, again, these are the same because you're squaring it. And so when you have y minus 25 squared, that's the same thing as doing y minus 25 times y minus 25, right? Multiplying it by itself, and that's exactly what the box is doing. Okay, so then what do I write now? What do I start with here? First I write, don't forget to write your 4, because it's not 1. We're going to have to remember to do something with that. Then here we're going to write y squared, and then how many y's? Minus 50 y's, and then plus 625, and then what's left? The plus 1. Now, what do I need to do in this case because of the a? Here I'm going to take it and I will distribute it. I need to distribute that 4 because now you do the exponent, now you do the multiplication. So 4 times y squared, 4y squared, 4 times negative 50, negative 200, 4 times 625, 2,500. And then the 1, remember, you don't distribute to the 1 because the 1's not attached here. So then your final answer is, now you add the 1 in there according to PEMDAS, plus 2,501. So if you can take the time to really do it out and really write out your work step by step, I think you're going to find that you're really successful, but you got to make that investment, right? But I think if you make the investment, you're going to find it pays off. All right. Now, I do have 2 you try activities. So here's the first you do activity. Okay, so in this activity, what you're going to do is the same thing, but now it's all up to you. I'm not going to lead you through it. So what we'll do, pause the video, try to turn this into standard form, just like we've been doing. And then when you're ready, unpause, and you can see what I got. Okay, step 1. Remember, we're going to be doing the box. Okay, for the box, we're going to have p minus 9. P minus 9, because that's the thing being squared. So we have p squared minus 9p minus 9p plus 81. So that's p squared minus 18p plus 81. This is 1, so I'm good there. I add the 36, and I get p squared minus 18p. So I'm going to do 81 plus 36, and that is 117. Okay, so again, any questions, please make sure you go back, rewind, watch through this example again, and then when you're ready, we'll move on to the final you do. Okay, so here we go. Last you try, we have negative 2 times, in parentheses, m minus 2 squared plus 1. So we have the process there. Think about what we know about PEMDAS. Okay, don't forget our good old friend here, PEMDAS. Okay, go ahead, pause the video, turn it into standard form, and then when you're ready, unpause, and you can see what I got. All right. So here we go. Set up my box, and I'm going to do n minus 2 and n minus 2, because first I'm doing the square. So this is n squared minus 2n minus 2n plus 4. Okay, then remember you need to drop in the negative 2, n squared. Now this is going to be minus 4n plus 4. Okay, now we'll drop in our negative 2. So we have negative 2n squared plus 8n minus 8. And then you add the 1. So you get negative 2n squared plus 8n minus 7. Okay, so you're just going step by step. First, you're doing the square, the n minus 2 squared. Remember, you never distribute. You always do the box to keep it nice and organized. Okay. Then you do the multiplication, and in this case, right, multiplication, you're doing distribution. So negative 2n squared plus 8n minus 8. And then you're doing the addition last, right? The addition and subtraction with the PEMDAS comes last, right? So hopefully these two YouTube problems really reinforce some of the big things we've been talking about, and you were able to get this right. Hopefully you found this video to be helpful to you. We'll continue to work on these kind of expanding problems, but keep it up, folks. Don't forget to love math, and remember, you can do it. All right, thanks so much for watching, and you have a wonderful day.